Hey, this is Mr. Aiden from MrAiden.com, and this is the 2021 AP Calculus AB free response question number 4. So let's get to it. It's one of these questions where we have a graph. We have a graph of the function of f, and you can see it says let f be a continuous function defined from -4 to 6, and it says the graph of f consisting of 4 line segments. G is a function defined by g of x is equal to the integral from 0 to x of f of t dt. So it is a fundamental theorem of calculus question. So the students should be able to see right away that we have a graph of f, we have a function of g, and so this is a fundamental theorem of calculus. And if you can recognize that as a student right off the bat, you'll be able to do this problem no problem. And so it says, on what open intervals is the graph of g, remember g is our function here, concave up? And so remember, we got to think of what concave is, concavity, and especially concave up. And that is where we have the second derivative test. The second derivative is going to be positive. Okay, so up is going to be positive. The second derivative is the second derivative test is for concavity, and so we want to take the second derivative of g. We want to take the d squared y over dx squared of g of x. We want to take the second derivative. So the first derivative of this, function is going to be equal to f of x. So the second derivative is going to be equal to f prime of x. Okay, I'll say that again. If the first derivative of g is just f of x, so g prime of x is equal to f of x, according to the fundamental theorem of calculus, then the second derivative is going to be the derivative of your function. So we're looking at where does the slopes of this graph of f of x, where are they going to be positive? And you can see I have a positive slope right there. I have a positive slope right there. So that is from the intervals of -4 all the way to -2, and the interval from 2 all the way to 6. And so those intervals are going to be positive. That's when we are concave up, and your answers goes to the second derivative test and knowing how to use the fundamental theorem of calculus. Now we get to part B. My students love part B because we're just taking the derivative of p, and p is this new function. So we are going to do the product rule. So p of x is equal to, let's do the product rule, g prime of x times f of x plus g of x times f prime of x. Okay, and so we're going to do that. And now we're going to do p prime of 3, which is going to be g prime of 3 times f of 3 plus g of 3 times f prime of 3. And I love for my students to write out all of these things. It makes it so much easier. And so I got to think of what's g prime of 3. Well, remember, we said g prime of x equals f of x. So that's equal to f of 3 times f of 3 plus we have g of 3 times f prime of 3. So let's take a look at what f of 3 is. F of 3 is right here. That's equal to -3. What's f of 3? -3. That's equal to +9. Okay, and so we're just staying consistent. We're just trying to answer our questions right here. And then it says, what's g of 3? Well, let's think of what g of 3 is. G of 3 is the integral from 0 to 3 of f of t dt. So that's the integral from 0 to 3. So I have to take a look at what's the areas underneath here. You can see the area from here and here. They cancel out, don't they? So the positive area and that negative area cancels out for everything in here and everything in there. Now I'm going to have to take a look at the areas here. The area here is -1, -1, -1, and -0.5. So that means this area is equal to -3.5, which means I can come back to my question. He's -3.5. And then it says, what's f prime of 3? So at 3, what's the slope of this line? And the slope is up 1 over 1, it's positive 1. So we have negative 3.5. You add those two things together and you get positive 5.5 right there. And that is how you do this question when we have this composite function right there. Take the derivative, write everything out, and then you're just reasoning each piece of that problem. Now we got part C. Part C says find the limit as x approaches 2 of g of x over x squared minus 2x. And what you want to think right away is let's use L'Hopital's rule. And so let's use L'Hopital's rule. L'Hopital's rule, we're going to take the derivative. Okay, so let's take the limit of x approaches 2 of g prime of x over 2x minus 2. And now let's think about this logically. G prime of x is equal to f of x, doesn't it? Using that you can see how the fundamental theorem calculus is just so key to this problem. So what do we have is, now we can plug this in, and we have g prime of 2 over 2 times 2, that's 4. 4 minus 2 is 2. So what's g prime of 2, which is f of 2? This is f of 2 over 2. What's f of 2? It's negative 4. Negative 4 over 2. Negative 2 is our answer. And that was using L'Hopital's rule. Okay? All right, let's move on to part D. Part D, it says find the average rate of the change of g on the interval negative 4 to 2. So let's take a look at what we're doing here. We're trying to take a look at the average rate of change. And that term average rate of change should make you think derivative, which means we're taking g of 2 minus g of negative 4 over 2 minus negative 4. Okay, and remember, the g, if we think about what's g of 2, that's the integral from 0 to 2 of f of x dx, which means what's my area from this value here and this value here, and of course that area is 0, isn't it? And then g of negative 4, g of negative 4 is from 0 to negative 4 of f of x dx. We're taking the area from 0 to negative 4, and because we're going backwards, these will become negative areas because we're going backwards. 0 is kind of like our frame of reference here. So if we think about this this area here, this area is 1/2 base times height for this whole triangle right here. So we have 1 times 6, so that's a negative 6 for that guy right there. This one right here, we have 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. This little triangle right here is going to be 2 times 2 is 4, divided by 2 is 2, so negative 2. So that gives us negative 16. So 0 minus negative 16. 0 minus negative 16 all over 2 minus negative 4 is 6. And we get 16 over 6, or 8/3. So the average rate of change is 8/3. Now the next question says, does the mean value theorem, does the MVP guarantee? Well, what do we know? We know that this this g prime of x is dependent upon this graph right here, and we know that is continuous. That is continuous. So we know g is continuous. And we know it is not only continuous, but it is differentiable. And so if a function is continuous and it is differentiable, that means the mean value theorem will apply. The average rate of change is 8/3, and we know there will be a g prime of c that will be equal to 8/3 because it is continuous and it is differentiable. And that is question number 4 for the AP Calculus 2021 exam. Thanks.